You bought two spherical beach balls. The larger one has a diameter that is twice the length of the smaller one. What's the ratio of the surface areas of the beach balls? Well, I don't know. We're going to have our first beach ball with a specific surface area of 4 pi r squared. And this one's going to have a surface area also of 4 pi r squared. The more you write the formulas, the more you'll remember them. So let's read again carefully. The larger one has a diameter that is twice the length of the smaller one. Okay, so what's the diameter here? I don't know. I have no idea what it is, but I do know that whatever this is, it's twice that one. So picture is clearly not drawn to scale. If you wanted to, you could just like make up a random number. However, what I'm going to do is say, well, okay, well, if this one has a diameter that's twice this one, then it also has a radius that is twice this one. Okay? So whatever this is, it better be double that. Again, don't go by the picture. Go by the words. The larger one has a diameter that is twice the length of the smaller one. So the larger one has a radius that's twice the length of the smaller one. So what I'm going to do is pick on the smaller one. I'm going to call that radius x. So now that we know the radius is x, then this one had better be 2x. I like to start with the smaller one. If I pick this one to be x, that'd be 1/2 x. It works. It's just going to get a little clunky with fractions. Just saying. So let's keep driving. 4 pi times the radius, which is 2x squared. Now what are we doing? Here, last sentence, what's the ratio of the surface areas? That's going to be a comparison. So 4 times pi times x squared. All right, well, there's no simplifying you can do here. There is some that you can do here. So you're going to have 4 times pi times, well, 2 squared is 4, and then you're going to have x squared. And then 4 times 4 is going to give you 16 pi x squared. So our larger beach ball has a surface area of 16 pi x squared. The smaller one has a surface area of 4 pi x squared. So to really answer the question, which is what we're going to do over here, read the last sentence again. What is the ratio of the surface areas of the beach balls? So I'm going to just do a ratio where it's going to be the larger beach ball to the smaller beach ball. And I'm going to get 16 pi, let's make that a pi, not an x, 16 pi x squared over 4 pi x squared, and lucky us, we have the skills to cancel some things out. We're going to cancel out the pi and the x squared, and it's going to leave us with 16 over 4, which is 4. So the final answer is this. The larger beach ball has a, let's abbreviate, surface area that is 4 times the smaller beach ball. Ah, good to know. Okay, here's what else you could do. And what I'm about to say is, we're like, why didn't you do this from the beginning? Because I wanted to show you that it works regardless of what you pick. I could have made up numbers. I could have just been like, you know what, you're 20, then you're 40. You're 11, you're 22. You're 175. Well, you're 2 times 175, which I'm desperately trying to do in my head right now, 250. Yes. Yeah. No, 350. That's it. Yeah, 350. So whatever this is, you double it to get the other one. All right, let's move on to the next one. So as I look at this one, what's the ratio of the surface areas of the two cylinders of equal height, where the first cylinder has a radius that is equal to the diameter of the second? So if it helps to draw a picture, you can. I'm not going to. What I am going to do is deal with, well, two surface areas. So surface area here of two cylinders. And again, draw it if you want to. I said I wasn't, but you might want to get a little visual for it by looking at, well, your notes, which I am about to use my notes if I could find them. They're just sitting around here somewhere. There they are, sitting under some scrap paper. So we're going to have a radius and a height. And in this case, the heights are going to be the same. So when I write the formulas, I'm going to have 2 pi r squared h. Whoops, 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 whoops. Don't put that h. Don't put that h. White out, white out. White out alert, white out alert. 2 pi r squared plus 2 pi r h. So same thing here. 2 pi r squared plus 2 pi r h. So I'm going to come over here and I'm going to say, well, I don't know what the heights are. Let's use a different color. Let's use black. I don't know what the heights are, but they better be the same. So the height is equal to what? What do you want it to be? It doesn't matter. Pick whatever you want. I'm going to pick 1, actually. It's going to make your life easier. Trust me. All right, where the first cylinder has a radius that is equal to the diameter of the second. So we're going to pick a radius over here. Pick whatever you want. And if you're like, let's pick 1. Yeah, pick 1. Pick, for real, it's going to work. Pick 1. But now I'm going to come over here and I'm going to say, well, you know what? In this case, the diameter is 1, so the radius is 1/2. Things are going to get a little tricky with that fraction, but we'll deal with it. All right, let's keep driving. Take your fast car and keep on driving. We got a fast car. Fast enough that we can drive. Fly away, actually. 2 pi times 1 squared plus 2 times pi times 1 times 1. Okay? 2 times pi times... Now, by the way, you could have let the diameter be 2, which would mean that this is 2. The numbers will work out a little better. You'll avoid fractions. But you know what? We're into this now, so let's go. Plus 2 times pi times 1/2 times 1. All right, we're going to keep working on both of these, and we're going to get numbers for each of these. In this case, we had variables involved and things canceled. In this case, I'm not doing it that way. Just don't feel like it. So we're going to have 2 cylinders. This cylinder is actually larger than this one. It has a radius that's equal to the diameter of the second one. So yeah, 2 times pi times 1, that'd be 2 pi. 2 times pi times 1 times 1, that's 2 pi. This one's going to have 4 pi as its surface area. All right, so this is 2 times pi times, let's see, 1/2 squared is 1/4. And then we have 2 pi times 1/2 times 1. 2 times 1/2 is going to give me 1 pi. All right, 2 times 1/4 is 1/2 pi plus that. So here we have 1/2 pi plus 1. Well, we have 1.5. Let's do decimals. 3.5 pi. So what we're going to do is compare them. And this one is larger. We're going to do larger divided by smaller. That just seems to be the pattern. Doesn't have to be. And so we're going to have 4 pi divided by 3.5 pi. And clearly, the pi's are going to cancel. Let's mark them out in red. And you're going to be left with 4 over 3.5, which is gross. Let's not. So 4 over 3.5, I'm going to multiply the numerator and denominator by 10. And that's going to give me 40 over 35. And then I'm going to divide them both by 5. That is not the most efficient way to do it, but I think it's the best way to explain it. I get 8/7. All right, so if I will white out the page number, I'll have room to write my answer. Here goes. The larger cylinder is, and I'm pausing to make sure my work is correct. I do believe it is. 8/7. Let's reword this. Has 8/7 the surface area of the smaller cylinder. Take the smaller cylinder, multiply its surface area by 8/7, you'll get the larger one.